Everyone. Now we are going to solve LeetCode number 3, which is called longest substring without repeating characters. It's a medium question, and it can also be solved with many different ideas, but what we are going to use is a hash map. So let's talk about the problem. So given a string S, find the length of the longest substring without repeating characters. So what does that mean? Let's see an example. Here ABC is a substring which do not have any repeating characters. So if we looked at ABCA, like here, it has a repeating character which is A. We do not want that. So the answer is ABC in this example. So here, as you can see, all the substrings has repeating characters if it is greater than one length. So the answer is 1 because the only substring that doesn't have repeating characters is B. In this example, we have 3 because this part doesn't have any repeating characters, right? Note that this says substring, so it has to be consecutive positions. So let's see some constraints. It says 50,000, right? So what we can do in this question is that we are going to start from a point. Let's consider this a string, and we continue to a right position, and let's say the string has like very distinct characters. Over here it has X character over here, and we see another X on the right hand side. So we will use 2 pointers, and we will try to maximize the distance between these 2 pointers where no character repeats itself. So if it has X here and it has another X here, the answer should be like this part or until this part, whatever the answer was. So we will always try to update the answer, and whenever we see something repeated, then what we are going to do is we are going to update our left pointer to the position where it doesn't occur for the first time. So we will have to keep track of the last occurrence of each character on our string. So what we can do is basically we can use an integer array because we know that there are a finite number of characters in C++, let's say, but also we can solve it by using a hash map. I keep saying hash map, but whenever I say that, I say it like that because it is the general name, hash map, but in C++ we have unordered map in its place. So let's try to solve it. By the way, let's first handle the edge case where s.size is smaller than or equal to 1, which means it has no characters or just one character. In that case, the answer, of course, is the size. If it has no characters, the answer should be 0, and when it has one character, the answer should be 1. So other than that, what we are going to do is we are going to keep an answer character right here, answer integer, and we are also going to keep an unordered map of character integer pair. Okay, so let's call this pos, naming the last position of any character. Okay, so we will keep track of the last occurrences of each character. So let's start writing the code, but let's keep a left pointer which is going to be called L conveniently, and we are going to use another pointer which is going to be called R. So what we want is basically R to be smaller than N. What is N, by the way? Let's define that. N is the size of the string itself. So I do not want to use s.size every time, so I will write just N. So R must be smaller than N because we cannot go away from the string's endpoint, right? So that's why we need a right pointer and this condition over here. So every time what we are going to check is we are going to check if the character on the right pointer already is in the hash map we keep for the longest substring. So how can we check that is like this. We are going to search for that character, which is going to be SR, right? So if this is equal to position.end, which means it doesn't occur in the hash map, it is not in the current longest substring. It has this meaning. So if that is the case, what we are going to do is we are going to add it to hash map, and we are going to do nothing else in this case, because we just increase the number of elements in the hash map right now. So that is SR. And the value of this thing, the key is this value is going to be the last occurrence index, which is R. That's the case. So what if the element is not is inside the hash map? So we have seen the same element like in this X case here. So then what we are going to do is we are going to update the L pointer, but where? So the answer is going to be position of S, the last position of S plus 1. So what is the reasoning here? Let's see. So basically the X had the position L, right? Previously, this position. Let's say I, and our L is here, okay? So when we see X again right here, we will have to start from one position later, because otherwise we will have repeating characters, namely X. So this L pointer should become right here, should come right here, one position later than X. So the problem with this, there's a small bug here. We will have to know that this thing is greater than L. Otherwise we could have like, let's say we updated this and we have another character like Y over here, and we see another Y later on. So because we updated L before, when we see another Y, we will have to update L just after this position of Y. So that will cause some problems because we have now X's inside. So what we are going to do to handle this is going to be simply checking if this thing is greater than or equal to L. It's basically greater, but we do not need to check that every time. So we updated our L value, right? And what we are going to do is we are going to put this element's position to the end. So we are just updating the position of the last character we've seen. That's going to be R, of course. This is the thing. This is the idea. So yeah, that's it. And we are going to, of course, update maximum of answer and right minus left plus 1. Y plus 1 is basically comes from mathematics. It's just let us see an example. 0, 1, 2, 3, 4, 5. Okay, and we have left here and right here. So if this is inclusive, we have to subtract left from right, which will give us 4 minus 1, 3, and we are just going to add 1, which basically tells us this range plus the element on the left, or otherwise on the right. So every time we do this, we are also going to increase R, because we are going right and we are trying to increase the range. So at the end, what we are going to do is we are going to return answer. So if you get the idea, let's run the code. And let's see, then we can talk about time complexity. So let's check a smaller case. And this will return 1 already, we know that. So let's see, yeah. And let's make a big case over here. Let's see if this works as well. So yeah, it looks like good. And let's submit it. And it works. So let's talk about the time complexity here. Yeah, we have an unordered map, which means every insert and find will take constant time, O1, And here we just run this while loop just once because we always increase our value, which starts from 0 to n, which takes on time here. And every time we use find and like this insert, we use o1, so overall complexity becomes on. And of course space complexity is also on because we use an unordered map which will keep at first scenario all of the elements. So thank you for watching.